All right. Well, after doing the activity on the unit circle, now we are going to look at some more unit circle properties that you need to be familiar with. So let's just recall some basics about sine, cosine, tangent. Remember from previous courses, you might have heard that phrase SO, CA, TOA, which helps us remember the different ratios for the sine, cosine, and tangent functions. So first off, let's review that phrase, what it means. So SO, CA, TOA just means that the sine is equivalent to the opposite leg of the triangle over the hypotenuse. And again, this applies for right triangles. Cosine is equivalent to the adjacent leg over the hypotenuse. And the tangent is equivalent to the opposite over the adjacent leg. Now, from the unit circle, remember we learned that the order, just like the ordered pair x and y, that the order that it goes in is the cosine is your x values, sine is your y values. And the relationship on the order or on the unit circle is that the tangent function is always going to be y over x. So for right now, that's what you need to know as far as the unit circle, is that the tangent function is the y value divided by the x value. Now you might have seen these before, but these are called the reciprocal functions. And so we have the cosecant. That's what this one is. So if you want to write that down, I guess I'll write down the word here. And this would be the secant. And this is the cotangent. And the reason why they're called the reciprocal functions is because they are literally the reciprocals of the ones above here. So the cosecant is a reciprocal of the sine function. Reciprocal. So reciprocal is spelled R-E-C-I-P-R-O-C-A-L. Reciprocal of the sine. And this is going to be reciprocal of the cosine. And this is going to be the reciprocal of the tangent. And we'll look at some examples here in a little bit, but basically from the unit circle, you would just find, if I'm asked to find the secant of an angle, I would just take whatever the answer is and take the reciprocal if I was looking for the secant, I would look for the cosine of that value, and then whatever the cosine is, I would take the reciprocal of it. So the cosecant is reciprocal of the sine function, the secant is reciprocal of the cosine, and cotangent is reciprocal of the tangent. Now there's not really a great way to keep these straight. Now the easiest of these is the tangent and cotangent, to remember that those are reciprocals of each other. But oftentimes people have a hard time remembering which one's with which, as far as when they see CSC and SEC, thinking, well, which one's cosecant, which one's reciprocal of the sine and which one's reciprocal of the cosine. Some people would think, well, secant must be reciprocal of the sine because it starts with S. Don't do that. There's really no easy way to remember it. The only way that I remember it is that, or I used to remember it when I was first learning this, is that the sine, the S in sine is in the middle of cosecant. So that's how I remember it. Cosecant has the S in the middle, so that's referring to that's reciprocal of the sine function. The secant doesn't have that, so it's reciprocal of the cosine. So whatever you can come up with on your own to keep those straight is best, but if you want to use that trick, that's what I used to use when it was new to me. Let's talk some more about tangent. So we spent a lot of time in that previous activity learning about how to use the unit circle to find the sine and cosine. So now let's look at how we can use the unit circle to find the tangent with what we just talked about, that the tangent is basically the y values over the x values. So let's say if we needed to find the tangent of 90 degrees or the tangent of pi over 2. So when we look at our x and y values, remember this is x, this is y, we would take y divided by x, or the sine divided by the cosine. Well, 1 divided by 0 isn't possible. It's undefined. So if you're ever asked to find the tangent of pi over 2 radians, or the tangent of 90 degrees, or the tangent of 270 degrees, or the tangent of 3 pi over 2, those would all be undefined because you'd end up dividing by 0. So if you ever end up dividing by 0, your answer for that would be that it's undefined. So let's go over here at 0 degrees at the beginning here. So if I take 0 divided by 1, well, that's possible. That's just 0. So the tangent of 0 degrees, the tangent of 0 radians, the tangent of 2 pi radians would all be 0. Now let's look at the middle one here. Square root of 2 and square root of 2. If I divide those, if I take square root of 2 divided by square root of 2, my answer is just 1. Okay, now let's look at what the tangent of 60 degrees or pi over 3 would be. So we would take the square root of 3 divided by 2. Do that below. I'm going to do my work for this below the unit circle here, the space that you have. So we're going to take square root of 3 over 2 divided by 1/2. Remember what we've learned about as far as how to divide by fractions. We had that phrase keep, change, flip. So we keep the first fraction the same, change it to multiplication, and flip the other fraction. And when you do that, 2 divided by 2 would cancel each other out, leaving us with square root of 3 over 1, which is just square root of 3. All right, so now let's look at tangent of 30 degrees or pi over 6. This one's going to require a little bit more work, and you'll see why in just a minute. So we're going to take 1/2 divided by square root of 3 over 2. Just want to let this let me right. There we go. There. So we're going to do a keep, change, flip. The 2's cancel out, leaving us with 1 square root of 3. Now the problem is we can't leave a root in the denominator, so we're going to multiply the top and bottom by the square root of 3. So we get square root of 3 over 3. So that's this last one. So here's the pattern. So at the top, it's undefined, and then, or anytime the cosine is 0, it's going to be undefined. When the sine is 0, it's going to be 0. And then in the middle here, we have square root of 3, 1, square root of 3 over 3. So 1 is easy to remember anytime that we have any of them that are a factor, or if we're dealing with fourths of pi, or anything that ends in 5 on the unit circle, like 45 degrees, and 135 degrees, and 215 degrees, and so on. For all of those, the x and y would both be square root of 2. So square root of 2 divided by square root of 2 would just be 1. So I want you to, so you don't have to go through all that work that I just showed you at the bottom of the page to get the other two values, the square root of 3 and square root of 3 over 3. I would just memorize those two, which is pretty easy considering everything else that you could memorize. And then the only thing that you want to remember is, again, we're dividing the x and y values. We're dividing anything in quadrant 1, a positive divided by a positive would stay positive. In quadrant 2, that's where our x's would be negative. So if we divide a positive divided by negative there, your answer is going to be negative. In quadrant 3, everything's negative. And if I divide a negative divided by a negative, my answer is going to be positive. And over here in quadrant 4, the x's will be positive, but the y values will be negative. So when you divide that, you'll always get a negative answer. So in quadrants 1 and 3, the tangent will always be positive. In quadrants 3 and 4, the tangent will always be negative. And then they're always going to be related to these values. So we'll look at some examples to help you make connections to that. So let's look at this first example here, where we have the tangent of 5 pi over 3. So let's think about that for a second. In terms of the big unit circle, where would 5 pi over 3 be? So here's 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi would be down here. So that's going to be in quadrant 4, so it's going to be negative. And since it's a third of pi, it's going to be related to pi over 3. So my answer would be same thing, square root of 3. It's just that it's going to be negative square root of 3. This is my answer. So cotangent of 60 degrees. So cotangent, that's one of those reciprocal functions. So the first thing I'm going to do is figure out, well, what's the tangent of 60 degrees? So tangent to 60 degrees would be, would be square root of 3. So this is the reciprocal of that. So that's going to be the reciprocal of 3 would be 1 over the square root of 3. But the problem is we need to rationalize the denominator. We're going to multiply the top and bottom by root 3, and we get square root of 3 over 3 is our final answer there. I know I only did just 2 problems, but I want to see what you can do here. So I want you guys to try these next 3 on your own. Using what you know about the unit circle, I want you to find the tangent of 300 degrees, the secant of pi over 3 radians, and the cosecant of 3 pi over 4 radians. So why don't you guys go ahead and pause the video and hit play when you're ready to check your answer. Let's see how you did. So starting with the tangent of 300. So again, I can't show you what's going on in my head, so I'm just going to show you visually what I'm doing in my head to figure that out. So the tangent of 300 degrees. So I know that this is 270 down here, so that's 270 degrees. So 300 would be 30 degrees beyond that. So that's where tangent of 300 degrees would be, which ironically is the same as what we did earlier with 5 pi over 3. It's in the same spot. So tangent of 270 degrees would be also, just like we did before, it's going to be negative, and it'd be negative square root of 3. Let's look at the next one, secant of pi over 3. So that I can actually even just show you over here. So here's where the pi over 3 would be. That's 1/3 pi, so that's right here. The secant is a reciprocal of the cosine function. So the cosine of pi over 3 would be 1/2. So the secant would be the reciprocal of that, which would be 2 over 1, which is better to just write as 2. All right, let's think about where the cosecant of 3/4 pi would be. So I'm just going to use this diagram that I did for the tangent just to give a visual. So again, this is what's going on in my head. So this is 1/4 pi, 2/4 pi, 3/4 pi. So that's where I'm imagining where 3/4 pi would be. So, and that's in the middle. So it's the median distance. It's the medium distance. Remember, we have small, medium, and large. Your small distance is 1/2. Your medium is square root of 2 over 2, and your longer distance is square root of 3 over 2. All right, so this is going to be square root of 2 over 2, and it's the cosecant, so it's going to be the sine. So that's going to be the y value there. So it's going to be a positive square root of 2 over 2, but it's the reciprocal of that because it's the cosecant. But we have to rationalize the denominator, so I'm going to multiply the top and bottom by square root of 2. So when we do that, we get 2 square root of 2 over 2, which ironically the 2's cancel out. So we just get square root of 2 for your answer for letter E. All right. Let's review some properties that we've talked about before. So remember that counterclockwise rotations, we're dealing with the unit circle, that when we go counterclockwise, that's going to be a positive rotation. And clockwise is negative. And recall that coterminal angle would be multiple revolutions of either positive or negative. So if you have an angle that is not between 0 and 360 degrees, that's not meant to look like minus, it's the interval between 0 and 360. Or if you have a radian measure that's not between 0 and 2 pi radians, then what we're going to do is we're going to add or subtract multiples of 360 degrees, if we're dealing with degrees, or multiples of 2 pi until you get a value on the unit circle to work with. So let's look at this first example. Here we have the sine of negative 210 degrees. So that's not between 0 and 360 degrees. So we're going to, in this case, add until multiples of 360 until we can get a number between 0 and 360. So if I take negative 210 and add 360 to it, we get 150 degrees. So in other words, this is equivalent to the sine of 150 degrees. Okay, now let's think about where that would be on the unit circle. So again, 180 degrees is over here. So 150 degrees is going to be just shy. It's 30 degrees away from it. So, and we're dealing with the sine. So we're dealing with a short distance going up to that value. So it's positive. So it's going to be a positive short distance. So a positive 1/2 will be your answer. All right, let's look at the secant of negative 330. All right, so the first thing I do is I recognize, okay, negative 330. That's not between 0 and 360 that I have memorized. So I'm going to change that by adding 360, and I get 30 degrees. So that means the secant of negative 330 is coterminal, to use a phrase that we've used or that we've learned, with 30 degrees. So that we want to find out, well, what's the secant of 30 degrees? Okay, so secant of 30 degrees. So again, let's use this unit circle that I had referenced here a second ago. Whoops. So 30 degrees, that's going to be right here. We're dealing with the cosine, so the cosine is horizontal distance. So that's a long distance to go from the origin over to that point. So the horizontal distance is the long, which is square root of 3 over 2. The problem is that's the cosine. We want the secant. So the secant's the reciprocal of that. So it's going to be 2 over the square root of 3. So then when we rationalize the denominator, we get 2 square root of 3 over 3 would be our answer. All right, let's look at this next one, 31 pi over 6. Wow, that's a big one. So sometimes you might have to do this more than once. There's a couple ways you could approach this. If you struggle with math, you might not recognize how many multiples of pi this would be. So let's just start with the first one. So just one multiple of pi. So I'm going to subtract. This is way more than pi. So now instead of adding 2 pi, I'm going to subtract 2 pi until I can get within a value between 0 and 2 pi. So I'm going to subtract 2 pi, but the problem is I need to have a common denominator, so I need to multiply the denominator by 6, multiply the numerator by 6, so I have 12 pi over 6 is the same as 2 pi. Now when I subtract those, I get 19 pi over 6. That's still too big. That's still more than one full revolution, so I'm going to subtract 12 pi over 6 again. And when I do that, I get 7 pi over 6. Okay, well, that's a sixth of pi. That's 7 pi over 6. We're going to deal with sixths. So let's think about where that would be. So again, using this unit circle at the top here that I'm referencing, because I can't show you again what's happening in my brain. So this would be 1 6, 2 6, 3 6, 4 6, 5 6, 6 6 would be at pi. So 7 pi over 6 would be right here. Personally, what I do is I don't count all of those in my head. What I would do is I would recognize that, 6 pi over 6 is the same as pi, so I'm going a sixth past pi. So at 7 pi over 6 would be right here. And again, we're dealing with a secant, so I'm looking at that's related to the reciprocal of the cosine. So I'm looking at a horizontal distance, that's a long distance. So that's going to be the reciprocal of square root of 3 over 2. So that would be 2 over the square root of 3. Oh, and it's going to be negative, because it's in quadrant 3, so it's going to be the reciprocal of that. So it's going to be negative 2 square root of 3. We just did that a second ago, so that's going to, after we rationalize the denominator, that's going to become negative 2 square root 3 over 3. So remember that the secant, again, is a reciprocal of the cosine function. So first figure out what the cosine value would be, and then find the reciprocal of that to get what the secant would be. All right, let's end with this one, and then I'll have you try some on your own. Cosine of 480 degrees. So that one's still, that's bigger than 360. So we're going to subtract 360 this time. Negative 120. So that's nice. So this is coterminal with the cosine of 120 degrees. So 120 degrees, think about where that would be on our unit circle. I'm going to go back up here to this one. So that's 30 degrees past 90. So we're finding the cosine. So the cosine would be the horizontal distance. So that'd be to the left of 0. So it's negative, and it's a short distance. So negative 1/2. All right, so on the back of your notes or on the next page, I want you guys to try these on your own. So go ahead, pause the video, and hit play when you're ready to check your answer. Hopefully you got the same answers that I got, and if you did, you're good to go. But if you didn't get the same answers, if you got any of them wrong, why don't you hold on a bit, and I'll go through each one of these. So starting with the first one, so we're trying to find the cotangent of negative 2 pi over 3. So the first step there is I would figure out what the coterminal angle would be. So I'm going to do that work first. So we would take negative 2 pi thirds plus 2 pi, which we would change to be 6 pi over 3. So we could add those together, and I get 4 thirds pi, or 4 pi over 3. So the cotangent of 4 thirds pi, where would that be? Well, I know 3 thirds pi would be the same as pi. So 4 thirds would be a third past pi. So that's going to be down there. Now we're dealing with the cotangent. So that's going to be related to the one that has a denominator of 3. Remember, we have the 3 values. We have square root of 3, 1, and square root of 3 over 3 are the 3 tangent values to remember. So this one, if it's got a denominator of 3, it's going to be related to the square root of 3. It's in quadrant 3, so it's going to be positive. So this will be a positive square root of 3 would be the tangent, but we're dealing with the cotangent. So the reciprocal of square root of 3 would be 1 over square root of 3. And again, it would be positives, but we have to rationalize the denominators. So multiply the top and bottom by square root of 3. We've done that already in a previous example, and so that would simplify and be square root of 3 over 3. All right, so that's letter A. Letter B. Let's look at that one. So for that one, we're going to start with, again, finding a coterminal angle with negative 7 pi over 6. So I would add 2 pi, which is equivalent to 12 pi over 6. So when you add those together, you get 5 pi over 6. So cosine of negative 7 pi over 6 is coterminal with the cosine of 5 pi over 6. So where is 5 pi over 6? Well, 6/6 would be same as pi. So 5 pi over 6 would be a sixth away from pi. And we're dealing with the cosine function, so that's the horizontal distance. So that's a long distance, so it's going to be negative square root of 3 over 2. All right, going down to the letter C there. And let's start with finding our coterminal value there. So to find the coterminal value, we would take 31 pi over 6. Now this is the same example that we did earlier, but I'm going to show you a slightly different way to do it. Because in the previous example, remember we took subtracted 12 pi over 6 once, and then we had to subtract 12 pi over 6 again. Now if you recognize that just one multiple isn't going to be enough, what you could do is remember, we could use multiples of 2 pi. And so a multiple, in this case, of 12 pi over 6 would be multiplying it by 2, or maybe multiplying it by 3. So taking 12 times 3 would be 36. So that's not helpful because that's going to be too big to subtract. But if we take a second multiple of 12, so 24 pi over 6 would represent 2 times around the unit circle. So now that gives us our answer. 31 pi minus 24 pi over 6 gives you 7 pi over 6, which again, if you look at the previous example where we did that for the previous letter C, we got the same answer. Just showing two different ways to get to the same answer there. All right, so now we want to find the cotangent of 7 pi over 6. So 7 pi over 6, that's a sixth beyond pi. So we're going to go down here. So that's a sixth beyond pi. So again, it's dealing with the cotangent. So that's related to the one that's over here. That would have 6 in the denominator. So that would be square root 3 over 3. But we want the reciprocal of that since it's dealing with the cotangent. And whoops, I just noticed something here. This should be positive. So if you're hanging around here because you're wondering why that was negative, that was my fault. It should be positive because in quadrant 3 it's going to be positive there. Because a negative divided by negative is a positive. So we would have 3 square root 3. Or 3 over square root 3 would be the reciprocal of that. And then we just have to rationalize the denominator, which would give us 3 square root of 3 over 3. Simplify that, we just get positive square root of 3 would be your answer there. All right, lastly, letter D. So letter D, we're trying to find the cosecant of negative 630. So first, let's find the coterminal angle. That would be 90 degrees, because just like we did in the previous one, if you wanted to, you could we would add 360 once, and it's still going to be negative, add 360 a second time, then we'd get 90. Or just recognize adding 360 isn't going to be enough, so a multiple of 360 would be 360 times 2, or 720, so negative 630 plus 720 would be 90. So the coterminal angle would be 90 degrees. So we want to find the cosecant of 90 degrees. Well, 90 degrees is up here at the top. Whoops. So it'd be up here at the top, and that's where the y value, so the sine, we're trying to find the cosecant, so we're looking for the sine value, is going to be 1 up there. And the reciprocal of 1 is still 1. So that works out pretty nicely. All right, so hopefully you have a better understanding now of the unit circle so you can do those problems in your worksheet.